This is section 2.5, part B. And the question we're going to investigate in this particular video is, does every function have an inverse? In order to answer that question, I'm going to start out with the function f of x equals x squared, just a parabola that we're all very familiar with. And let's just quickly fill in this table of values. Negative 2 squared is 4. Negative 1 squared is 1, and so on. All right. We know from what we were doing before that if there is an inverse function, we should be able to simply reverse the x's and the y's, and that will give us a table of values for that inverse function. So I'm going to write down the reversed table of values. There we go. And I now want to consider this question. What's the problem with that table of values, and why would we have an issue with calling that an inverse function? In order to answer that question, think back to our original definition of function. Every input x must have only one possible y, or output, that goes with it. And of course, that's not the case in this table. For example, the input 4 has 2 different outputs. Or the input 1 also has 2 different outputs. This is not a function, is it? The same x value corresponds to 2 y values. All right, we're going to come back to this in just a minute, because if you're all sort of thinking, well, gosh, what's the problem here? I mean, why is this happening? Because if I just told you the function was x squared, probably the sort of normal reaction would be to think, well, then the inverse function must be the square root of x. We're going to come back and talk about that a little bit more in just a few minutes. But let's first of all discuss this a little bit. In order for a function to have a true inverse, it has to be what we call one-to-one, meaning that not only does each input have exactly one output, but also every output must have only one input. That way, when we reverse the table, we'll still have a function. Again, f of x equals x squared fails to be one-to-one because, for example, when x is negative 2, y is 4, and when x is positive 2, y is 4. We now have an output that has 2 different inputs. That's fine for a function, but it's not okay for a one-to-one function. So this function is not one-to-one. So again, when we say one-to-one function, we really have 2 things that function has to satisfy. To be a function, every input has exactly one output. But to be one-to-one, also every output has exactly one input. So we're adding an extra condition on our function in order to make it one-to-one. Let's take a look at that condition graphically. Here's a graph of the function y equals x squared, or f of x equals x squared. And often it's easiest to decide whether a function is one-to-one simply by looking at its graph. If I look at this graph, I can certainly see that it passes the vertical line test, right? Any vertical line will pass through the graph in only one point. So the fact that it passes the vertical line test tells me this is a function. Now we have to kind of look the other direction. Let's mark a location on the graph of 2 points that have the same output but different inputs. An example would be right here at x equal 4. There's many examples. Well, actually, let's pick one that we didn't use before. Let's go up here to 9. At 9, the output 9 corresponds to the inputs -3 and +3. Notice that this horizontal line at y equal 9 goes through 2 different inputs or 2 different x values. Right? That's going to be the same at a number of other points, actually infinitely many more points. If I were to just draw a couple of them, a horizontal line goes through more than one point on the graph. This is outputs that have 2 different inputs. For this reason, we usually say that we test to see if a function is one-to-one by using the horizontal line test. This graph fails the horizontal line test, meaning that it's not one-to-one. Returning for just a minute to the idea of why isn't the inverse function for x squared simply the square root of x, the answer actually lies in the fact that when we make the definition of square root of x, we decide that that square root is going to be a positive number. Right? We've dealt with this a few times when we were using the square root method to solve quadratic equations. We said that if we just put the square root in, we're only going to find the positive solution. We had to force ourselves to put in the plus or minus to get the negative solution. What's happened is that we've essentially looked at only half of the original graph of f of x. And we've defined our square root function as being the inverse of just that half. If you go on and take more math, you'll talk about that in a little bit more sophisticated way in later courses. But I just want to give you a preview here. So the square root of x is not technically an inverse function for the true x squared graph. It's really only the inverse for half of the x squared graph, a restricted part of it. And I'll leave it there for now. All right, let's practice applying our vertical and horizontal line tests. We want to determine whether our functions are one-to-one by using that horizontal line test. Here I'll point out very quickly that it certainly passes the vertical line test, so it's a function. If you think of the horizontal line test, well, let's see, that horizontal line only hits in one place. That horizontal line only hits in one place. Right? Try one up here. Only hits in one place. So this is looking like it does pass the horizontal line test. And it is one-to-one. All right, what if I give you the function in its formula form rather than its graph form? Well, this is a lot harder to deal with when we're trying to determine if it's one-to-one. So my recommendation on these is to simply graph them on your calculator. If I go ahead and put this x cubed minus 4x in my calculator, and I'm just going to use a zoom standard negative 10 to 10. If you look at this graph, it's probably clear to you pretty quickly that there are a lot of horizontal lines that would cross through this graph more than once. I don't think this one's going to be one-to-one. I'm just going to sketch this so I can make that a little bit more clear in my notes. I'm seeing something that looks kind of like this. And although there are horizontal lines that only hit once, there are also many, many lines that are going to cross that graph several times. And so that graph does not pass the horizontal line test. It's not a one-to-one function. Just to note, it does pass the vertical line test. It's still a function. It's just not one-to-one. Okay. So only one-to-one functions have true inverses. This one's going to have an inverse. This one would not have an inverse. All right. We'll talk about looking at one-to-one functions in a more algebraic way in terms of the actual formula, in more of a symbolic way, in the next section of the video.